It's a little supermassive black hole. So it's about 6 million times the mass of the Sun.
CERN is pushing the limits of science and redefining what we know about reality itself. With the power of a quantum computer, researchers have taken a bold step into the unknown, unlocking parallel universes. But it raises a serious question. If parallel universes are real, what does that mean for us? Understanding CERN and its mission. CERN, which stands for the European Organization for Nuclear Research, is one of the world's largest and most respected centers for scientific research. Located near Geneva, on the border of Switzerland and France, it began its work in the mid-1950s. The main focus at CERN is high-energy physics. Researchers here try to figure out what makes up matter and why our universe works the way it does. Scientists collaborate from all around the globe to advance our understanding of fundamental particles and forces. Over the years, CERN has become famous for running the Large Hadron Collider (LHC). This impressive machine is the largest particle accelerator ever built. It has a ring-shaped tunnel about 27 kilometers in circumference underground, where particles like protons get accelerated to speeds close to the speed of light. The collisions that happen inside the LHC allow scientists to study the tiniest components of matter, testing ideas from particle physics that try to explain how our universe is put together. Scientists have many goals at CERN. A big one is to test and expand what's called the Standard Model of Particle Physics, a framework that describes particles and forces, except gravity. Although the Standard Model has many successes, it doesn't explain every mystery in physics. For example, it doesn't fully account for dark matter, dark energy, or the exact nature of gravity. That's where more advanced experiments come in, often designed to look for new particles or unknown physical processes. CERN is not just about one machine or one experiment. Multiple detectors sit along the accelerator ring: ATLAS, CMS, ALICE, and LHCb. Each experiment looks at collisions from a distinct angle. These detectors help scientists explore a wide range of phenomena, from studying the properties of quarks, the building blocks of protons and neutrons, to searching for signs that might hint at hidden dimensions. Because of the complexity and large volume of data produced by these collisions, CERN depends on huge computing resources, which increasingly includes research into quantum computing approaches to handle and analyze that data. People often link CERN to big scientific achievements, such as discovering the Higgs boson in 2012, but the organization's scope goes beyond that. Thousands of researchers worldwide stay in contact with CERN's data centers, drawn by the chance to understand how the universe formed and how it might work at the smallest scales.
We all know that digital computers changed virtually every aspect of our life.
The latest development from Google that it describes as a state-of-the-art quantum computer chip.
What if I told you that one of the most advanced quantum computers in the world, Google's Willow,
Google's Willow chip is touted as not just another technology breakthrough,
was reportedly shut down under mysterious circumstances? Was it a technical glitch, a groundbreaking discovery, or something far more dangerous? In this video, we'll uncover the chilling truth about these claims and how an ethical hacker's shocking findings changed the game forever. Let's begin. The quantum revolution. Imagine a world where impossible calculations, problems so complex they could cripple today's fastest supercomputers, are solved in seconds. Well, this is the transformative potential of quantum computing. Once the stuff of futuristic dreams, quantum computers are now reshaping what we believe is possible. Recently, a mysterious event at Google raised questions about whether humanity is truly ready to harness such power. According to insiders, their latest quantum chip, Willow, was suddenly and unceremoniously shut down, a decision cloaked in secrecy and intrigue. What was Google hiding? And what could be so alarming as to halt one of the most ambitious projects in technology? What one ethical hacker uncovered goes far beyond technical glitches, but to understand the gravity of these events, we need to rewind to 2019, when Google launched its quantum processor, Sycamore, with a bold claim. quantum supremacy. This moment was heralded as a giant leap for humanity. Sycamore, a superconducting quantum processor with 53 qubits, performed a task in just 200 seconds that would have taken a classical supercomputer roughly 10,000 years. This breakthrough demonstrated that quantum computers could surpass even the most advanced classical machines for certain types of problems, a moment described as the Kitty Hawk of the quantum era. Apart from being a huge milestone for Google, it was also a challenge to the world, ushering in an era of unprecedented computational capability. But Sycamore wasn't the end of the line. Just years later, Google introduced Willow, its next-generation chip. Willow boasted capabilities that made Sycamore look like a prototype by comparison. Early reports suggested it could perform in 5 minutes what a classical computer would need over 10 septillion years. Yes, septillion, a mind-bending figure almost impossible to grasp. Yet in December 2024, if rumors are to be believed, Google abruptly announced the shutdown of Willow. No formal reasons were given. Theories ran wild. Was it a technical failure, a security breach, or perhaps the chip had done something unforeseen?
Some physicists raised on determinism had trouble accepting this new probabilistic view. Albert Einstein famously said that he didn't believe God plays dice with the universe. But there is another related, even stranger aspect to quantum mechanics. In classical physics, external reality is independent of the observer. Looking at the moon doesn't change the moon. And if you look away, the deterministic laws of physics continue to guide the moon on its path. But in quantum mechanics, things are weirder.
The basic idea of quantum mechanics, the thing that we really struggle with to get our heads around, even as professional physicists, is that unlike any other version of physics, quantum mechanics separates what happens in a system when we're not observing it from what we see when we measure it.
How do you guys think about quantum computing in the context of your overall computing, industrial computing business? What do you hope to achieve? What are some of the challenges that you see in ultimately making quantum computing successful?
Yeah, so I'll start. Thank you, Jensen.
Great to see you.
It's wonderful to be here and to be with all of you as well. When we think about quantum computing, at Microsoft, obviously we have a large cloud, right? We have many customers, and it's really about that, right? We want to ensure that we are empowering our customers, whether they're enterprises or scientists, right, practitioners, with the most powerful quantum computing at every moment in time. And so that means today and tomorrow, right? We are a platform company looking to bring forward a quantum computing platform to enable new scenarios, new applications, right, emerging capabilities and disruptive capabilities.
For everybody's benefit, what technology